Welcome to qnawire.
So let's consider that the direction of the turntable rotation as positive direction. Then we can apply the conservation of angular momentum in the system, and by system I mean runner and turntable, to find out the final angular velocity. Now the initial angular momentum is I times omega 1. By 1 I mean the initial velocity of the turntable, or initial angular velocity of the turntable, minus mr v1, where this is the angular momentum of the runner, and there's a negative sign because the runner is running in an opposite direction. So that's the initial. Let's call it L1, and for final, let's call it L2. For final, the runner comes to rest. So the total angular momentum is omega 2 times I plus mr squared, where this is the total moment of inertia of the runner and the turntable. So that's L2. And from the conservation of angular momentum, we know that L1 is equal to L2. And then if we set them equal to each other, we have, and solve for omega 2, we see that omega 2 is equal to I omega 1 minus mr v1 divided by I plus mr squared. So the given values are the moment of inertia of the turntable, which is 80 kg meter squared, omega 1, or the initial angular velocity, which is 0.2 radians per second, then the mass of the runner, which is 55 kg, the radius of the turntable, which is r, and that's 3 meters, v1, or the linear velocity of the runner with respect to earth, which is 2.8 meters per second. Now if we use all the numbers over here, we see that omega 2 is negative 0.776 radians per second. And I think it's pretty clear from the negative sign that this indicates the turntable has reversed its direction of motion. So this happened because the man, or the runner, had larger magnitude of angular momentum initially. So basically, since this guy was bigger than the initial angular momentum of the turntable, that what that made is the system started rotating reverse, in the reverse direction from where the initial direction was for the turntable. Thank you.